Hello, everyone, and welcome to the next edition of the 30-minute workout series. I'm Alan Gilbert, a technical specialist at Autodesk, and I'll be joined and assisted by Angel Espinosa and Jeff Bartles. They'll be taking questions, so if you want to enter those during the presentation. Today's topic is closure analysis with the Traverse Adjustment tool in Civil 3D. This topic was requested actually the last time I presented on the 30-minute workout series. I did Traverse input using the Traverse tool. And we had several folks ask if I could continue and talk about some of the adjustment options to adjust that data within that tool, because they're really brother and sister tools. And so that's where we are today. Thank you for joining. If you've been here before, welcome back. If this is your first time to the 30-minute workout series, just to give you a little background of what this is all about. As you know, in traditional training, a lot of times you learn what you need to know to do your job. And it takes years to learn all the other tips and tricks and things like that. And the goal of the 30-minute workout is to shorten that learning curve. Some of the ground rules for the session, you'll see some examples that are a little more abstract than real world. And that's intentional, just to get the point across or to teach it a little bit easier. We always start and end on time, and these sessions are recorded, and you'll get a link to that probably sometime early next week. Please place your questions in the Q&A pane that you see at the top instead of the chat pane, if you don't mind. And Jeff and Angel, and maybe Jerry may make a late appearance. He got caught up on a call, but they will take your questions as we go through, and we'll probably have a little time where they may feed me a few live questions if there's something specific. On to the agenda. So the agenda for today is, what is a data adjustment? Why do we want to adjust any data? Why would we do that? And those that are familiar with adjustments are probably very familiar with the survey database adjustments, which is where adjustments typically happen in the survey world. If you're not a land surveyor, that may not make sense, or not a survey processor. But that type of conventional survey data is where that typically takes place. So what's the difference in this? Why are we doing this here in the Traverse tool? And then we'll do two examples. We'll do a loop Traverse boundary adjustment. And I say close because it's a closed loop, meaning we start on a known fixed point. We know the coordinates or location, and we traverse around in a loop, and we shoot back or we observe, however you want to say it, that original point, and we close that loop. In the second example, we'll run a connecting traverse adjustment. Now, that's also a closed traverse in this case, so that's confusing to people that are not in the survey world. A connecting close, it doesn't make sense. But what a connecting closed traverse is when we start with a known point or two, usually two, and we traverse down a longitudinal line, like think about a highway down the side of a highway. And then we have two more known points at the other end that we shoot into and tie to. So when you think about going from a known point to a known point, it is closed. We're closing into a known point. If we start from a known point and we traverse away from that point and never observe or shoot into a known control point, that's an open traverse. Okay, so that open traverse is not something that this tool could handle. Now, since this is a little bit of a continuation of the property description class that I did the last session, I just wanted to put the name of that and the YouTube link that's on my YouTube page. But that's where I showed how to enter, or some tips and tricks for entering data into the Traverse environment. We did station offset. We did a lot of different methods to get that data in there. So if you're not familiar at all with the tool, you probably want to go back and watch that one. To give you a little context on how to get data into the tool. This is a PowerPoint free zone. And so this is the conclusion of the PowerPoint, and we're going to go live in the software from here on out. So remember, the first item on the agenda was why would we adjust, and what's the difference between this and the survey database? Well, in some cases, it could be the same as a survey database, but why would we adjust? When we have data that is observed, surveyed with some type of instrument, in the field, we're returning distance and angles. That data, there's error propagated, is always some error between the traverse that you do. So think about a loop. Think about starting from this point down here. And this is a known point in red, and we traverse all the way back. Well, my observation line, I'm going to shoot this known point with my survey instrument, but really the finish point, and that's drastic, but the finish point will be somewhere probably off of that point, because there's a little bit of error accumulated through here to get back to that exact point, because no instrument is perfect. Okay. So that's why you would adjust, but that doesn't mean that I only adjust survey data. I adjust any data that comes from survey form or that comes from mathematical form, meaning you'll find in your tax assessor's office or your county courthouse, maybe the deed, right? The deed for your property or whoever's property that you're dealing with. And a big majority of those deeds have never been surveyed by precise instruments. And where I live in Alabama, most of those deeds have not been surveyed at all on the ground. No one's ever went to the ground and observed any of those points. So what that means is there's error all over the place. And so even that type of data, you take data from a deed, an old deed especially, that's something you may want to close, because 99% of the time that will not close on itself unless it's a very simple deed and it's very old, where they say go 90 feet north, 90 feet east, 90 feet south, and so on, right? Where it's just a simple closed shape because there's really no math to it. Okay. And in the same example, my little fake drawing here, the connecting traverse is starting from a known point, a connecting closed traverse like we're going to see, and we're shooting distance and angle. And then we, at the end, we observe that finished closing point. But because of the error on all of these setups, because my instrument was here, here, and here as I moved along, I'm not going to hit exactly with my observed point here. So I'm going to have a point here, and I'm going to have a point where this should be. And that's called the closure error. So if you do a distance between those two, and there's no telling what this will be, but that is the amount of error in the closure. So you missed by that much. And again, there's many standards when you deal with closure as well. So there's surveys that you only close if the closure from the field doesn't meet a criteria, a various level, ABC 1, 2, 3, whatever the standard is. You may be going off a national standard, a local standard, who knows? Okay, so that's what we're talking about here, that misclosure. How do I basically take this point and move it here, but weighting the entire path? All of these points here that were set up, they're not known. How can I adjust those all to make this close? Because if I just take this and move it here, well, that assumes all of the error was in that last leg, and it could be. And that is one form of adjustments that people don't talk about a lot, is where you just have a bad leg on a traverse. And so you may, in some cases, make a selective adjustment. In other words, you don't assume that there is the same amount of random error in every leg of the traverse. Okay, so that's really the why. And then the difference between the survey database is we can enter data like it was entered in the field if we had hand counts, but the survey database, it manages the import process. It manages multiple shots on points. It manages that conventional format of total station data, distance and angles. So when it's in that conventional form, you're going to want to run the traditional traverse analysis in the survey database. But this is when I have data that's already done, right? It's already in, more of a fixed form, right? I already know the location of the points, but I still need to run the closure. So let's move to the first example. This may look familiar from my last session if you were there. I hope you were, but this was a highway job, and we have a plat for this particular lot here. Okay, and in that session, we showed how to enter the data into the Traverse editor. So I'm not going to go back through that. That takes a little too long. But what I'm starting with is I have a point number 1. In my Traverse, I saved it. It's already based or starting from this point, and we're going to go around the property and close back on 1. Okay. And we're going to run an adjustment on that particular property. So this is more like pulling a deed or a tax or a plat off of a county or tax assessor website. So to bring in the traverse, again, this is the tool we talked about in my last session, Traverse Editor. This is just to get the data in, enter the data manually, or I'm going to open an existing traverse. Okay, because my point said to occupy point 1, it went right to that location. And we talk about that in depth in my last session about how using a point can make your life so much easier. You don't have to locate this traverse. Okay, because I didn't tie this to a COGO point or a known point, this would not jump to the right spot. And then it was just direction, distance all the way around. And let's look physically at the misclosure before we do anything. Is it, does it close or not? Well, it doesn't take very much zooming here to see the misclosure. So you can see where I've got 0.7, and that's the point that my actual, whoever surveyed this, their closure point was. And 0.1 is where it should be. 0.7 should be exactly on top of 1 if this was perfect, but there's no perfect survey. Okay, and you can even run the distance command to check how far that is, right? You can just type in distance and roughly see what the misclosure is. Okay, so it's very small because this is pretty much or almost a closed traverse. Okay, so let's run the analysis and let that close. We're going to run to the balance tool by clicking here. This is a shortcut. Another way to go is from the home menu, traverse adjustment. 2 ways to get there. So I'm going to load the balance tool. It asked me to save another file. That's okay. This keeps, and I can overwrite the first file, but I'm going to keep the first one. I don't want to mess it up, basically. Okay. So here at the bottom of the settings, I just want to show we have multiple. This is your numerical method or statistical analysis. Compass is one of the most common for this type of data because compass rule assumes that angles and distances are measured with roughly the same accuracy. Some of these older methods like transit was before the electronic distance measurement devices on total stations. We taped all the distances, but we could turn a really tight angle because we had electronic angles, but we couldn't get the distance very well. So, but we're just going to run compass here. Again, it's just a statistical analysis, and compass method basically takes the error. So what is the error? Let's look at it here on the input. We're about 4 thousandths of a foot off. So almost close. And for most any order survey, this is good, right? You wouldn't even have to do this. This is showing again, just as an example. But there's 4 thousandths of error in the closure. That's what 0.7 missed 0.1 by. And here's your precision of that, 1 in 114,000. And when you're talking about a 470 foot survey, that's really good. Okay, so we really don't need to do much here. And what the compass rule does is it says, okay, I'm going to adjust each leg of that traverse, and I'm going to make it a function of the length. So a longer leg gets more of an adjustment, shorter gets smaller. Okay, so it is relative to the length. In other words, we don't just put a number on each leg. So you have really long legs, that is going to get more adjustment. Okay, that's the way the compass rule works. So the compass rule is automatically applied here. Notice my start point, end point, and point of closure are perfect. So start point is 1, the traverse end at 7, and it should have been 1. Okay, so but when it's a loop traverse, the tool will pick it up immediately. You don't have to do anything. Now, if you do want to look at the angular, so there is angular error too, right? Because when you have a closed shape like this, if to find the sum of the angles inside the shape is n minus 2 times 180, you may remember from math class, that gives you the sum, of the shape's interior angles. Well, I'm going to have error in that too. I'm never going to hit exactly, if I survey a triangle, I'm never going to hit the n minus 2 times 180, which is 180, right? So if I click angular balance, I can also balance the angles if I would like. So what was the angular misclosure? Well, it tells us that up here too. It was 9 seconds out. So you missed your n minus 2 times 180 by 9 seconds, roughly. Okay. So I can turn that on and it'll adjust the angles first, and then it will run the compass rule. Now, if I just hit done here, nothing happens. This is just, I'm just testing here. But if I want to apply and keep this, I need to click the apply adjustment, and it's going to ask me to save that final traverse file. So I have the new computed points. And now I have the TRV2 file that I can use in another file. So I could go now and import that, just go to the traverse command in a brand new file and open that and use as I would like. And now I have a nice closed boundary. Okay, let's move to the connecting example, connecting closed. A lot of similarities, but a few major differences. First thing we knew is I need to bring in my control points. And I did this last time, but I'm going to just quickly bring in using the create points import. So I have 4 control points. I'll show them to you once they're in. And I'm going to add these to a point group because that's how I roll. I'm going to fit the screen, and I'm going to flip the scale up so you can see these better. Okay, so I have 4 points. And this connecting traverse is going to go here, start from here, backside here. It's going to do a bunch of courses, and then it's going to shoot back into here. And it's going to finish up with a foresight into this known point. So we're going known point with a backside into a known point with a foresight. So let's bring in that traverse. We'll go to the connecting. Okay. So we start here, boom, 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 all the way around back to here. And then there's our known line. So these 2 lines have known azimuth or angle. These 2 lines here, because that's between my fixed points. But I need to adjust everything between. That's what I'd like to do. Let's look at the misclosure. Where can you see the misclosure? Well, it's really easy to see it here. So point 188 was my fixed point that I imported from the file. But point 2000 is here also. You see the 2 points offset? Or 2000, 200 is the point that I shot. Okay, so let's go balance that. So we'll go to the angular adjustment tool, and it wants me to save that. So I'll just call this adjust. I could overwrite. Make this small again. There we go. So my precision is horrible. My closure is 5,000 feet. So that doesn't, I mean, there's a problem, obviously. If you even look in the graphics, you can see what the control line thinks it's doing here. The tool is all confused. But when you have a connecting traverse, you've got to tell it a little more information because it can't guess. So it sees my starting point is 191 up here, and it says, oh, that's probably the first point. And it's like, no, that's not. My fixed point that before I start going into non-fixed points is 190. Okay. So in other words, I can't pick 191 because the next point is a fixed point that does not get adjusted. So I have to put in 190 here. And then remember, when I get to the end here, my last fixed point, or where I finally shoot into a fixed point 188, I shot point 200. So point 200 is my end point. And you just saw 200 should be the point of closure, which is 188. That's the fixed point, control point. Okay. So you can have fixed points between the 2 points here, start and end. And then you have to have a real point to compare to. All right. So now let's take a look at the closure. I've got 1400ths of pure closure area, so that's with a 11,000 foot survey. That's, real world is what, that's actually really good, to be honest. Okay. Depending on the order of your survey, you may not need to adjust this, but probably so. Okay. This shows you what compass would do for that, because compass adjustment automatically shows you what it's going to do if needed. Okay, in blue, you can see all the results. I can generate a report. But what about the angular? Can I do angular on a connected closed traverse? And the answer is yes, if you have enough data. You have to turn a final angle to get that. And it may not be as legitimate as a real survey conventional data to do this angular balance. But what I can do is there's an angle difference, a bearing distance. So you've got 200 where my traverse finished. I've got a distance down to 0.185 in direction. And then where it should be 188, I've got, of course, a known direction and distance. So that delta between those two angles is my angular misclosure for this tool. Okay, and I can distribute that angular error throughout all the angles of the traverse, and it does, this tool only does it evenly. It doesn't let you pick. But let's just show you how to do it. So we're going to turn on angular balance. And again, it's completely confused. It doesn't know what to do because we don't have a loop like we did before. It doesn't just obviously know what your directions are for your closed or your closure direction and your observed. So we just said that the observed direction in the traverse was from 0.200 down to 185. So I need that direction, and the tool gives me an option to do that. If I type in 0.200 and put 3 periods, dot, 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 and then the next point down at the bottom, the known point is 185. Okay, that will compute that direction, and that's in the help file, by the way. There's several tricks like that in the help file if you take a look. And then what the actual real direction should have been is from 188 down to 185. So I'll type in 188 dot 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 185 tab. And now you can see the angular misclosure initially was 8 seconds. And again, with this length of a survey, this totally makes sense because this is more of a real world survey versus the previous one was like a tax assessor type parcel. Okay. So now that angular error, if I turn on angular balance, it's going to take that 8 seconds and distribute that off in between all those vertexes that are not known, those angles, and balance that angle. And then at the end of that, it's going to do your compass rule and adjust and close that 0.14 1400ths closure error and make that 0 here. You can see, or as close to 0 as it can. You can see that in blue. So if I apply this adjustment, I'll just take both. And it asks me to save that, of course, your final, new adjusted. I can hit done, and I'll just go into a new drawing. And I can go to Traverse Editor and open that final. And you can see this is post adjustment. So everything's already been adjusted. All of the angles have adjusted. All the lengths of the segments have been adjusted. And we are complete. We have a finished adjusted traverse. So going back to the PowerPoint, today we looked at why would we even adjust in the first place. Talked about briefly the difference in the survey database. There's a lot of differences. Don't feel bad if you don't grasp all of that because there's lots of little nuances there. And if you're not processing survey data, don't worry about it. It's not a big deal. And then we looked at a closed loop traverse boundary where we close back on a known point. We start at a known point, close back on the same one. And then we looked at adjusting a connecting closed traverse where we're starting with some known points, traversing through into and ending on fixed points to close, in quotes, close that particular boundary. So I know we're close to time, but we got a few minutes left. Jeff or Angels, do we have any questions that we need to take live here before we close?
Yes, there are a couple of questions, Alan. The first question is there any way to also adjust leveling runs?
Yes, in the survey database, but not in this particular tool. Yeah, this particular tool does not adjust level data. That would have to run through the survey database.
There was another question. Does the angular balance discount the first known bearing?
First known bearing. Yes, for sure. Yep. Anything known is ignored for sure. It's only taking angle right from that first known leg. Yep, for sure.
I think that's the primary questions.
Awesome. Well, we'll close here, and I'd like to thank everyone for attending our 30-minute workout. This will be our last one for the year, and we look forward to seeing you all in the new year. And we hope everyone has a nice break. If you have some time off here in the next month or so, we hope everyone has a great break. Take care, everyone.